Right. Let's see if I can squeeze talking about the different update rates and some tips and tricks into the same video. So you can select how frequent you want the tree to be ticked. Continuous will tick in the update method of this mono behavior. Fixed update during the fixed update. Manual, you can reference a public method of the Koala brain from somewhere else and tick it. So for example, here I have a button and the button has an event with the NPC assigned to it, and inside the Koala brain I'm calling the tick method. So if I run this, there we go. I can tick once and you can see it perform just the first action, and then it stops because the tree is not ticking anymore. So I tick again and it runs the second one, and I tick again and the third one, etc. So yeah, you can tick manually your trees whenever you want. You also have the timer option. So here I'm saying to tick every 5 seconds, and each coroutine takes about 2.5 seconds. So I will start it, see it wait for 5 seconds, and then perform the first action. Then it will wait for around 2.5 seconds and go to the next action, and etc. Let's see that working. So the beginning is not very interesting because we have to wait for the first 5 seconds. And then it runs the first one, waits for a little bit, and runs the second one, and there it goes. So you can also time the ticking of your trees to perform certain behaviors with a fixed update rate. Then you have the option to repeat or not the route. So right now all the examples have the repeat route checked. So now I can uncheck it, and as you would expect, it will tick on the tree as long as the root node has not returned a success or fail. So right now it's always running, so it's ticking on it. But once it succeeds, it doesn't do it anymore. But you can click on it and it will do it. This means you can, during runtime, change this value and stop and start your behaviors at different times. This works also with the fixed update, but it doesn't play well with the manual or the timer. The timer should always have the repeat route set on. Okay, so another interesting thing is that sometimes you're running a tree. So let me make a copy of this tree. So I'm gonna select it and duplicate it, and I'm gonna take it to my tutorial folder, and now I'm gonna assign this new tree here, and I'm gonna change the name to trick. Okay, so let's say I'm working in my tree and I have created this action that moves to the origin. And now I want to create a new action to move it somewhere else. So the standard way to do it would be to grab an action node, put it there, change the name to something like move 500, then fill the parameters 500, and then the speed, and then create the event, and then assign my Koala move actions and the method I want. So it's all click and drag and stuff, but it takes a little bit of time to set each node up. So it would be good if I could reuse them. So I'm going to save my tree, and then I'm going to go to it, and I'm gonna grab a copy of what I want. So for example, I can grab the first node, the move 000, and then assign it here as a sibling, and it makes a copy, but this copy moves independently, so I can now call it like this, and you can see that the name only changes in this one, and it's not yet inside my tree, but when I save it, you can see that now I have my copy. So you can reuse nodes that you've already pre filled with information with a specific method, for example, or a specific name, or etc., and reuse them from inside your own trees. This is also true if you take any tree, for example, let me show you this one, the priority sequence. And this one, if I grab a node that has children on it, it will bring the children with it too. So this way you can really design modularly, and you can reuse pieces of trees or complete trees, right? So this is an interesting ability. So one final thing I would like to show you is that although this library is meant to be used like in a visual way, clicking and dragging and rearranging and filling things up right in your editor, it is also true that you can do it programmatically. So there's a script with an example that I would like to show you, and this script uses the Koala behavior tree namespace, and it creates a tree by coding. Each node on the tree is a scriptable object, and I'm just creating instances depending on what I want the node to be. So I start with a tree, then a selector for my root, then I assign the newly created selector as the root of the tree I created, and then I create a sequencer. I create instances of scriptable objects that hold methods and conditions, the Koala move actions and the Koala conditions, and I store them with the postfix SO for scriptable objects. Then I create 4 action nodes, and the action nodes again are scriptable objects of type action node. And for each action node, I will create an event that I will attach to the onTick event of the action node. And then I add listeners to the event. So here I'm adding this method called moveToBack from the Koala move actions that I created up here. Then I fill the parameter of my node, and then I add it as a child of the sequence. The second action does the same, the parameter is a bit different, and it shows that you can add more than one listener to the same event. Now this is useful, but it's also tricky because the action will return its status once the first event has finished. So usually you should have one event that drives when the action is finished, and then you can add other methods that simply perform differential stuff. For example, this my method is defined up here, and it simply debugs the string that it's passed. A second important thing is that all listeners share the same parameter. So again, you should have one listener that will require it, and the rest of your listeners should really not pay attention to the parameter. I add 2 more actions, and then I show you how you can set up condition nodes. And the only thing you have to do is define the can run method, which is the Boolean method. And here I'm taking my scriptable object with Koala conditions, and passing the return true method. You can see here that I'm passing methods, but so I don't include the parentheses afterwards because I'm not calling them, I'm just passing them as the function that should be used to compare the condition method. This means that you can define your conditions on the fly using lambdas. You can define a anonymous function that takes a game object and a string, then do something with them and return a boolean. Here I fill the parameter with this string, so this will appear here when this condition node is ticked. Finally, I set up the Koala brain on the game object to have this tree and this root and set up the rest of the things I need. And I change its update rate to fixed date update. So once that's done, what should happen is that even though no brain is assigned, no behavior tree is assigned in the brain, if this script is running, we should see that the NPC is driven by the behavior I just defined. So let's see how that goes. Okay, that's the first action. In the second action, I also called this method, and then it's doing the whole sequence. And here is calling the last condition where I defined it via a lambda expression. And now you can see that I can repeat the root and it will do it again. But one disadvantage is that you cannot see it in the editor. This is because in order to edit inside your inspector, this editor needs to work with serialized trees. That means trees that we've already saved in our serialized version. So it is possible to build these trees and while you're building them, actually creating the assets in the editor, but at that point it sort of becomes useless to have them scriptable, because if you're going to build the actual asset, it's much more comfortable to do it just from your editor the whole time. But anyway, sometimes you want to do it by code, or some people prefer to do it by code even if they don't have the visual feedback, and I wanted you to know that it is possible. On that note, one last trick of the sorts is this idea that you can attach more than one listener to your action nodes. So let me just add an action node here, and you can add more than one condition here. For example, let me put this one and select something, and then I can add a second one. But here I was telling you it's a bit tricky. You should really be careful with how the coroutines and stuff are working, because only when the first action tells the node that the action is finished, then the behavior in the tree will start ticking again. So this is good if you, for example, want to use this event when this happened, something in the UI pops up or something like that. This can be a good way to do it. Okay, so that's it. Thanks a lot for listening. I hope you enjoyed. Please leave comments, and bye.